So for learning target 4.2, the nice thing about the test and the review is notice that the graphing grid is already set up for you, so you don't have to figure out where the axes are going to go. These lines will actually fit on the grid with this origin centered on the graph. That's not always the case, and I wanted you to practice ones where you have to think about where that point of intersection is and where to put your axes, because that's a pretty important skill. But once it comes to actually doing the quiz and test, I just want to know, can you graph those two lines, know how to do that, and know how to find the point of intersection? So, when I'm looking at this, and the way this is copied on your paper, you should have plenty of room down below each graph to do any work that you need to do. I know from the first equation that the y-intercept is -3, and the slope, or the rise over run, is the coefficient of the x. Now that's a 1 in front of here. So if I write that as a fraction, it's 1 over 1. So I already know from my first line I'm going to need to go down to -3. And again, since I don't have to think about where my axes are going to go, I can just go ahead and say this one crosses at -3. I rise 1 and run 1. Now, I would recommend, again, doing those points across your graph to make sure that when you put your ruler down, you line this up beautifully. Make sure that you are using a straight edge on your graphs. Make sure you're putting the arrows at the ends of your axes and at the end of the line that you are graphing. Because they are lines, they need to have arrows. Now, my second equation, the y-intercept, where it crosses the y-axis, is +3. The slope, which is the rise over run, is -2, the coefficient of x, so that's turning it into a fraction, -2 over 1. Which means I need to go up to +3 and put that scale in. I go down 2 and to the right 1, and again I'm going to carry that pattern across my paper, and I've already found my point of intersection. Now, because my point of intersection is out here, I need to label my x-axis out to cover that point. And then I'm going to, oops, let me undo that. I certainly didn't mean to do that. I'm going to draw my line through those points. Now, my answer is not the graph. The graph is the work that you need to show. The answer is the ordered pair +2, -1, because that is the point of intersection of those two lines. Now, on this first equation, we have x minus 3y equals -3. When it's in standard form like this, with the x and y on the same side, the easiest way typically to graph those, it's not the only way to graph them, but usually the easiest way, let's substitute 0 for y. When I substitute 0 for y, 3 times 0 is 0, x minus 0 is just x, and I get the equation x equals -3, and I don't even need to solve that anymore. When I put 0 in for y, I solve and get x is -3. Now, that's the x-intercept. To find the y-intercept, put 0 in for x. X is 0. 0 minus 3y is -3y equals my -3 on the other side. To solve for y, I'm going to divide both sides by -3 to get this y by itself. So y is +1. So this line's going to cross the y-axis at +1, and it's going to cross the x-axis at -3. Now, let me get my line drawn in. And I'm going to have to do a little bit of fixing on this line. Sometimes I don't line it up very well when I'm graphing these. Your ruler should line up much better. And again, remember that you have arrows at the ends of your axes. You are using a straight edge on all of your lines. My second line is in slope-intercept form. So when I want to go ahead and figure out how to graph that, I know my y-intercept is -3, and my slope, which is my rise over run, is +5 over 3. So I need to go down to -3 on the y-axis and put a point. Rise +5 is going to take me up to here. run positive 3, and there's my point of intersection. So I'm going to need to take my y-axis, my scale up to 2 to cover that point, and I'm going to have to go out to 3 on x. Now I'm not done. I do actually need to graph that line. So when I graph the line, let me get that in there. And again, I'm going to have to mess with this just a little bit. Sometimes it's hard to line this thing up perfectly the way that this program works. There's my graph. I have my scale out as far as I need. I have arrows on the ends of my lines. I use a straight edge for my lines. Now, to actually answer the question, the point of intersection is the point positive 3, positive 2. And the last one, these are both in slope-intercept form. I'm not even going to write the work down for these. I'm just going to graph them. So I need to go down to negative 5 because the y-intercept on the first one is negative 5. The slope is positive 3 over positive 4, so go up 3 and to the right 4 and put my second point, and then I'm going to graph my line through those 2 points. The second line, the y-intercept is negative 1, so it crosses the y-axis at negative 1, a slope of negative 1/4. A negative slope falls, the line falls as it goes across the page. So I go down 1, and if I go down 1, I have to go to the right 4 so that the line will fall as it goes across the page. And again, that's already my point of intersection, but let's get the line draw through because that's showing your full work that is required. You don't just plot points and stop, you actually have to have the lines. There's that line. Now, in all 3 of these cases, the lines do intersect in a single point. So my answer in this case, I need to take my x scale out here. 1, 2, 3, 4 will cover that point. It's the point positive 4, negative 1. Reminder, if when you graph it you get 2 lines that are parallel and they never intersect, your answer would be no solution. And then tell me why it's no solution, parallel lines. If when you graph one line and then you go and graph the other line, it turns out that they're really one on top of the other, your answer would be infinitely many solutions because they share an infinite number of points of intersection. And why is there infinitely many solutions? Because it's the same line. So your answer is going to be one of these things. It's going to be an ordered pair when there's a single point of intersection. It's going to be no solution, parallel lines if the lines are parallel. And if they're the same line, you're going to write infinitely many solutions, same line.